All right, everybody, let the record show that Harris is back in his seat now, so we may begin. Harris, thank you very much. Okay. What we're going to do today, guys, we are going to wrap up the conversation that we had on metars yesterday. We're going to pop into something else and then to some other things. So here we go. Please extinguish your devices, except for the proceedings up here at the front of the class. Thank you so much. Now, metars. Questions on metars. Anybody have questions now on metars, with the exception of remarks? Just forget remarks.
We're not doing remarks.
Oh, my Lord in heaven. It's just, we can't get people to decide on remarks. At some point, if I can talk to somebody with the weather service who can actually explain to me what the heck is going on metars. And by the way, I've asked.
You should do that and add to this.
And that could happen.
But
Okay.
even,
Yes.
like when you go on to the aviationweather.gov and you hit decoded, I was trying to like puzzle through what some of the remarks would mean, but they don't really.
No, they don't even list them.
They don't include it in the decoded.
Do you know why they don't put remarks in the decoded section?
Maybe they're not.
Because they don't know.
Then why are they even in here?
Look at the code and see.
Do you understand now what I'm talking to you about the FAA? We love them. FAA, we love you. But sometimes, so this is kind of the thing, okay? So yeah,
Okay,
so there it is. So we're not going to worry about it.
just forget them.
All right, there we go. Understand, when are metars issued?
Every hour.
Every hour, okay? Are they all at 7 minutes to the top of the hour?
No.
No, some are 4, some are 9, some are 11,
Some are 3.
okay? All right,
Some are 0.
all right. So they're issued every hour. How long do they last? An hour, right, until the next one. Or until something else happens.
Until something major weather happens.
Special, thank you very much, until a special. Okay, that's kind of the thing. So conditions are changing. Now, you get a metar, so here you are. You're 30 miles out. Well, we're in small training aircraft. You're 20 miles out. Okay, here you are. You're 20 miles out. You get the metar for the field. Is that exactly what's going to happen when you get there?
Not quite.
What about if it is at the top of the hour?
It'll be pretty close.
It'll be closer, correct. It'll be closer. What about if it's 45 minutes after the hour?
It could be kind of different.
So we call that stale. We call that a stale metar, okay? Because again, it's like the further away you get from the moment of issuance, the more stale that becomes. And I will also suggest to you that this time of year, this time of year, we look outside, of course, here at the beautiful compound here in Aspen, Colorado, and it's snowing for the first time since when? Yeah, I know. Those of you that are thinking about coming to Aspen for that ski vacation, come on! All you Texans, come on! Anyway, the thing about those is the fact that seasonally, you know that by mid-afternoon or so, stuff's going to kind of start changing because things warm up, we start getting that convective activity, that air mass stuff starts moving around, that air mass stuff presents itself in the form of wind somewhere near the airfield, and that could definitely affect your plans for your landing. Okay, all right? Kylie?
How do you make sure that you have the accurate weather, like especially in places like Florida and things, where 1 minute it's totally sunny and the next it's pouring rain?
Uh-huh. Or like Aspen, where 1 minute it's this and then the next minute it's that.
Yeah.
Yeah, how do you know?
That has like a more like situations and precipitation.
This goes back to one of the very first things that we talked about with regard to weather theory. There are certain parts of the country at certain seasons, at certain times of the day, that if you don't like the weather, just wait 5 minutes. Things change that quickly. Here in the mountains, they can change even more quickly than that. And they can be vastly different in a 10-mile span from one valley to the next. You could have one valley that could have almost a complete different ecosystem compared to the next. That's how different things are. So to answer your question, how do you make sure? How do you make sure? What do? Okay, looking outside's not a bad thing. What else? Okay.
You would get maybe different weather reports
From whom?
different areas.
Different weather reports from whom?
From pilots.
Pilots could be a thing. Pilot reports, that could be one. What about this? Air traffic control. So that's going to be in talking to someone in the system. Okay, that's going to be either the Denver Center, Fort Worth Center. It can be, somebody there asking about, some other weather. They're going to give you more generalized stuff. You'd have to kind of visit more with the airports themselves to get more accurate what's happening now kind of stuff. But even as you get closer, like here, when you get the ATIS. ATIS stands for what? We went over this. ATIS, ASOS, AWOS. We wrote those down. Terminal Information Service or System, depending upon which publication that you read. So you get that. That's kind of the verbalized METAR, right? But in a METAR, it's written. So your wind conditions are true. You hear it from the ATIS and you hear and you hear someone's voice, it's magnetic. If it's written, it's true. If it's spoken, it's magnetic. But they give you the weather in the exact same format as a METAR. That's why you have to know the format, because you're going to be tested on that. To know that the very first thing that you get is the airport identifier, then you're going to get the date and the time, then you're going to get what? Winds. Okay? Winds. Visibility. Sky conditions. Temperature and dew point. Altimeter. Okay? All of those things, the ATIS gives you that. The ATIS also gives you airport operational information in addition to the weather. My point is this. They issue those on an hourly basis. So if you're landing at like let's say 11:45 and you're 13 miles out and you hear that ATIS, even that could be stale. Don't be afraid to ask for current conditions. Don't be afraid to ask for instantaneous winds. Because normally the winds that they give you are a 10-minute average. When it gets tricky and that wind starts to blow, I want to know what are the instantaneous winds. Because anytime that I'm coming into Aspen and I'm lined up on 1.5 and I'm a mile and a half out and I see the wind socks do this, snug up that strap just a little bit, So anyway, yeah, that's kind of what you want to do. Does that answer your question?
Yes.
The only thing that I was getting onto you there is that when I'm speaking,
Sorry.
it's all right. Okay. Now, so METARs, we kind of get that, kind of understand it. Secret handshake of being a pilot. There you go. Okay. Next thing we're going to talk about is what? Pireps. What is a pirep? Pilot report. Yes. Yeah, it's the one thing that almost acronym that kind of makes sense, almost, because we think about a METAR, a routine aviation weather report. METAR makes perfect sense. Hang on here. This was a student. Can I do this without messing up the broadcast? I don't know. I'm not sure who just sent me the text message here. Let me see. I don't know who this is. I think it might be Tyler. So anyway, Tyler, if you're watching the broadcast, sorry about your day here, but hopefully you can tune in and catch all the fun. So, back to this. One of the more useful elements of an observation, remember we're still talking about weather observations here, is a pilot report. Because this is someone who has been there, done that, got the t-shirt. They have just flown through perhaps that weather mass that you're headed toward. And they can give you real-time data. What kind of data do they give you beginning with the very first thing? What do they do? What's first? Look above the bullet points. Look above the bullet points. What's first? What's the difference between UA and UUA?
UUA is urgent.
Correct. UA is normal. UUA is urgent. The first time that I saw a pirep pop up on my for-flight screen, I saw UA and I thought, oh, United Airlines, great. Yeah, but that's not the way it is. UA, which stands for routine. Naturally, UA. Okay, so that's kind of what it is. Here's a normal one or here's an urgent one. Okay, and then after we kind of go through these, we'll talk about why you would do one over the other. So now bullet points. What do we got? Where are you? That's the first thing. Pirep, where are you? Over what location? How do you tell them over what location? What do you say? I'm over Mount Sopris?
No, you give your coordinates.
Coordinates, what kind of coordinates? Compared to what?
Longitude and latitude.
Would you do compass?
Have you read this section? That was a rhetorical question because I can tell you haven't. Okay? It's in relation to a VOR. Take a look at the paragraph down below that begins in quotation marks. Pirep 12 nautical miles northwest of MDB, Mike Delta Bravo. Anything that gives you 3 letters is going to be a VOR. A VOR is a ground-based radio navigation station. Not everybody is going to know where Mount Sopris is. Not everybody is going to know which pile of granite Capitol Peak happens to be. But they're going to know the VORs. They're going to be able to find them, and they're going to be able to fix your position based on your report from your distance and your direction from that reporting station, that VOR. That's what we do. Okay. Next. Time. What kind of time?
What the time is.
Time is what kind? Zulu. What kind of time do pilots do we operate in? Zulu. Okay, so we give our time in Zulu. Next. Altitude or flight level. What's the difference?
Altitude is how high you are above the sea, and then flight level is how high you are above the surface.
Say it, Diego. What do you got? Oh, you're getting close. Over where? Gavin's got it. 18,000 feet and above. So below 18,000 feet, we're going to report an altitude. I'm at 11,500. 14,500. This is as a VFR pilot. If you're an instrument pilot, you are at 15,000. Notice that we don't say 15,000, because remember what I told you before? We pronounce every digit. Okay? That is an altitude. That's how we say it. So we're at 12,500 over whatever that's going to be. Okay? If we are at 18,000 feet and above, we don't say 18,000. We say flight level 180. 22,000 feet, flight level 220. 41,500 feet, flight level 415. Got it? Okay. Next. Yes, Kylie.
So when you're pronouncing the digits, you wouldn't include all the zeros afterwards?
You don't have to. It's given. It's given because if you say the word flight level,
Yeah, you know that you're above 18,000 feet.
you're at or above 18,000. What's that?
It's kind of like how you do it with the clouds, like you add 2 zeros.
Sure.
Yeah,
Okay,
never
now
mind.
that altitude is MSL. Okay, you're not giving an AGL altitude. You're giving MSL. Okay. All right. Next, what's after your altitude?
Aircraft type,
Okay, what do you mean by that?
what you're flying.
Yeah, what am I flying? Correct. Am I in a 737? You know, am I in a Citation jet? Am I in a Diamond DA-40? That's kind of what you put. Okay. All right. And then the optional items, SK. Okay, a little different than this. Little different, so some sky cover. Next, WX. Okay, of the weather, what are we reporting here?
Visibility.
Your visibility, what your current weather happens to be. Next,
So all the ones from here down are optional?
no, now, well, you do have the first 5 are mandatory.
Yeah.
The first 5 are mandatory, but here again, if you're going to give a real pilot report,
You want to put as much-
now all you've done is just said where you are and what's happening, you know, around you. I want to hear the meat of it. The meat of it is what comes next. Okay, so now after your weather, what do you got? Okay, all right. So you've got temperature, wind velocity. How in heaven's name are you able to give a wind velocity report?
Pure speed versus ground speed. Or, no, indicated versus ground.
You're close. You're close.
Indicated and true, sorry.
True versus ground. True versus ground is going to be a place where you start. But in the G1000, what do we have?
You have true.
It does the mathematics for you. So it can tell you the wind velocity and the direction. Okay, so that's going to be one of the things that's going to be important here as well. Next, turbulence. Do you think around this part of the world we might be interested in that information? Yep. What else?
I think.
What about this time of year? You think we might want to know this information? Yep. Next, remarks. I pooped my pants. The weather is... Steph, I'm really trying to work with you here today on cheering you up today. And I'm just, I keep seeing your head do this. I'm so worried about your neck, dear, because I look over here and and I'm thinking about your chin bouncing off your, I'm teasing you. I'm teasing. Okay, so there we go. Now, let's look at the pirep that's on this sheet that we have right here in front of us. Let's look at this. What do we got? Talk us through it. Somebody. What kind of a report is it? It's a normal? Okay, so normal. Now we have a slash. Then we have what? Now you have your location between the 2 forward slash marks, right? Okay, all right. So you got the location. So you're 12 nautical miles northwest of MDB, wherever MDB is. Okay? Next. What is the time? 1540 Zulu. What time would that be here? Thank you. Next. Yes. No. That's, no. 840. 840. We're 7 behind. 7 behind right now. We're 7 behind. Go ahead.
Oh, yes. How could you, would you just know if it was AM or PM based off of what time it is?
Yeah, because they do it in military
So, like,
time.
if you'd be, so say it's 8:25 and the last report was at 7:54, you'd be like, oh, obviously it's in the AM because we're in AM right now.
No, it's in military.
Yeah, I know it's in military time.
So, like, it would be like 13, whatever, and then you know it's 1 o'clock.
That's the point of military time. There's no AM and PM.
Sorry for that waste of time.
Welcome aboard.
I was always thinking that.
All right, here we go.
Minus.
After the time, what do we have?
You need 7.
Our altitude. So in this case, even though it says FL, this is just an altitude. What's our altitude right now? 12,000 feet. MSL. Okay. Then we have what? Type. This is a Baron. This is a BE-55. Right now, the multi-engine the multi-engine aircraft plug-in that we have for our FMX is a BE-58. Just so you know. Okay. So next, what do we have?
Sky cover.
Sky cover. Okay. What do we got?
First cloud layer at 2,600 feet.
Is that your
2600 feet.
No, broken.
Wait,
Wait, broken at 2,600 feet, and then broken to overcast between 3,400 feet and 4,400 feet.
This is a little weird, and here's why I'm saying this. This report was given that this person is flying along at 2,000 feet, 12,000 feet. And they're giving a sky report of the fact that at somewhere at 2,600 feet, 10,000 feet below them, there's clouds. Not sure why this would be in there, but then we talk about another broken layer above that cloud at 3,400 feet with the tops of that broken layer at 4,400 feet. Okay? Then we have what's next?
Temperatures -11 degrees Celsius.
Then we have broken, and then you have a minus, which tells that you kind of have that intermittent overcast piece kind of going on there. Okay? All right. Then we have what? Temperature, and this is going to be in Celsius. So in this we have temperature is what? -11 degrees Celsius. The band that we are most concerned with as we fly through visible moisture, otherwise known as is going to be 5 degrees Celsius down to minus 15 degrees Celsius. 5 above, 15 below Celsius. That's the band that we're most concerned with. We know that there are also certain clouds that keep their moisture more at the top of these clouds, that we can also be in trouble even down to minus 20 degrees Celsius. So we kind of have that danger zone that we sort of work with. Are we in that danger zone here? Yep. Okay. So what would we expect given those visibility issues that this person has just described? We might be looking at some icing somewhere here. So after the temperature, now we have what? Icing. Moderate rime ice in between what levels?
6,000 feet and 8,000 feet.
Okay. So the way it appears is that this person has climbed out, wherever it is that they took off from, climbed out through these other layers, and then all of a sudden they get up to here, and they're talking about this rime between 6,000 and 8,000 feet. But it's interesting because have they described cloud issues between 6,000 and 8,000 feet yet?
No.
So it's a little interesting to me. That's all I'm saying. It's like,
Is this what is it?
yes, dear.
Is this what a normal pirate would look like, or is this kind of just like simulated
According to
FAA?
this, it will.
Is it supposed to have these results so we can like see like when the
Stand by.
Sorry.
Okay, remember, we have academics, we have real world, sometimes the two. Okay, so let's continue. So we have moderate rime ice. Rime ice, remember? What is the most dangerous type of ice?
The
Clear. Clear ice, that's the most dangerous. Rime ice is what? It's kind of a mix, because you get little bitty droplets, you could get little bigger droplets, you could have little air pockets in there, and it looks more granular.
Well, then wouldn't air pockets make mixed?
What's that?
Wouldn't air pockets in the rime ice make mixed?
Make it mixed? What do you mean?
Ice.
It can be. Yeah, but again, remember when we went through icing, you have various size droplets, and those various size droplets can do different things on primarily leading edges of whatever it is that you're throwing through the icing conditions. The little air pockets that kind of form in there as they kind of burble when they hit that, those can then be kind of a thing. The mixed thing is the fact that you have different types of ice versus kind of what happens here. The rime piece is going to be that granular looking kind of, gnarly looking stuff hanging out there like barnacles, the sailing term. So that's what's happening here. Then what else? Okay. Then we get to the remarks here, and then we have what? Turbulence increasing westward on a magnetic heading of 270 with a true airspeed of 185. Okay? So this is kind of what a transcribed pirep can look like. Now, And for those of you tuning in at home, I apologize about this because one of the problems that we have is actually showing the iPad on the computer piece. So this is going to be kind of a, oops, no, I didn't want to do that. I wanted to do this. Stand by. This thing, I must be in a bad spot here. Oh. Let's watch Netflix.
Yeah.
What the heck? I don't know what's going on there. Hang on. Why is this doing this? I don't understand. I guess. Well, I'm going to have to leave the seat of power here to walk around here and fix this. I don't know why this is. I don't know what's just happened here. I had this all set up. I can't keep anything nice. Oh, guys, I apologize about this. I see why. This skipped to this. That's what's supposed to happen. That's wrong. All right. So let's look here. Now, let's take a look at this. Let's take a look at this. Let's take a look at this.
Story.
Sorry.
Are you guys getting sleep at all?
No.
Yes.
Wow.
I am.
Oh, I can tell you've had sleep. Okay. Now, this is ForeFlight. This is a page in ForeFlight. So if I close this, you can see that we have several different things that we have at our disposal on the scratch pad here in ForeFlight. One of those things is the actual pirep template. So in this case, what do we have here? I could do that, or I can make it urgent. And I can submit this, upload it to the system, and then it can show up on the map. Yes, dear?
What makes a report urgent and how do you know if it's like urgent?
When you have unforecast phenomena that are occurring, we want to know about it. If we already know that you're going to climb out through something and you could encounter icing if you go this direction, well, that's on you because it's forecast. But if it's not, if this is something unexpected, that's kind of, especially if it's going to be severe, like turbulence. If you have severe turbulence, severe icing, my prayer is that instead of doing a pirep, if you encounter severe icing, you're getting your John Brown hind parts out of there and then do the pirep later. Okay, Gavin?
So why would you do a routine one if it's only going to be like
The only thing the reason that I could say it's just kind of routine is, let's just say, for instance, that you're flying through the mountains and someone has reported light turbulence and what you're feeling is more moderate.
So, can you correct them?
You can't correct them, but what shows up here in one of the very first things after your position? The time. So if I see somebody that says at 15:05 Zulu, they reported this, then somebody 20 minutes later at 15:25 comes through there through the same spot, and now it's moderate. What do you think the trend is?
It's gonna get worse.
And this is what I want to know if I'm following them. Make sense? So you can see that right here, we can say 5 south of red table, time, let's call that 1537Z. Flight level, we're going to say 14.5. Aircraft type, DA40. Okay? And we just do our positions right here. We write all this down. Then we call it in. Air traffic to ATC. I have a pirep. Now you just read it as opposed to trying to remember it. Okay. The other thing that we have at our disposal here, remember that whole thing with regard to like the ATIS that we get? Well, guess what? After a while, you kind of get the ATIS and you sort of file that stuff away. When you're first learning how to do this, sometimes it's helpful to do this. Information Bravo, time 1553, whatever that's going to be. And what's the first thing they give you? Winds. So winds, let's call that 260 at 15, gusts 20. Okay? Sky conditions, right? It's going to have your visibility. Visibility is going to be over here, right? Let's say in this case, 4 statute miles. Sky conditions tells you here with your layers at, let's say that you have a broken layer at 2,000 feet, and remember this is going to be AGL. Then you have another broken layer at 4,000 feet. Then you have overcast at 4,800 feet. Kind of see how this works? So you can kind of write down your ATIS, temperature, dew point, altimeter 30.02. Expect runway 15, remarks. Density altitude 8,700. Gavin.
So if you're doing this mid-flight, how would you have it set up in the cockpit?
In the cockpit, it's a couple different ways. I have it set up on my knee pad, so I can have this on a knee pad with a smaller iPad. Also in the stationary, I have a RAM mount that I have on the glare shield here where this mounts right here. So I have my primary flight display, my multifunction display, and right here I have my iPad. To me it is. I still have a knee board on my leg with paper. Why do I carry paper?
In case you're at
No. When all that stuff shuts off. Not in case. When. That's my mindset. When all this stuff shuts off, I still got a pencil and a piece of paper. Okay? Same thing. Okay? This is like why I also like to write this stuff down on paper as well. This can go away. Paper I'm probably going to hang on to. Make sense? Okay? You can look at those pireps. They give you several. Go through there. Make sure you know what they mean. Good so far? Oh, yes. Now, remember, at the very beginning of our conversation with weather, we go through the weather theory portion. Then we get into the weather types of tools that we have available to us. One set of tools are in the category of observations. The next set of tools come to us in the category of starts with the letter F. Forecasts. Forecasts. What is a forecast? It's a guess.
It's kind of like the projected weather for an area.
It's an educated guess. Here's what we think is going to happen. How accurate are they?
sometimes they're accurate,
I
sometimes
feel
they're
they're not really that accurate.
Depends on the source.
We're gonna get
Depends on the source.
I think I'd like to have a job of like either a weatherman or a major league hitter. Because where else can you fail most of the time and still have a job? Just saying. Forecasting. Our forecasting models have improved. They really have. In most of the plains states and places where there is not a tremendous amount of orographic interference, when I say that, what am I talking about? Thank you. The forecasting tools on a 10-day forecast now are as accurate as the 2-day forecast when I was in high school. Back in the late 70s, the 2-day forecast was about all you could hope for. Now, we're pretty good with a 10-day forecast. But when you start watching these, as I'm sure you all have, you'll notice things change. Last week, when I was looking here at the forecast stuff, weather-wise, is like flying in and out of our fair city, there was no snow in the forecast for today. Yet here we are. So over the weekend, that changed. Things change. They move around, and you have to kind of be aware of that. So know that the forecasting tools have gotten better, but are they perfect? Let's think for a second how difficult forecasting can be. And here's kind of what I'm talking about. Let's say that you're making a fruit smoothie. All right, here you go. You're making a fruit smoothie. What are you going to put in this fruit smoothie? What do we got? What do we got? Strawberries. We like strawberries in there. What else are we going to put in there? Like a little banana, strawberry banana. Dude, you're singing my song, mister. What's that? Let's put a little yogurt in there. I like me a what? Okay, wait a minute. Okay, so maybe some whey powder, a little protein in there. I've got strawberries, bananas, I've got yogurt, and then someone said spinach. Ice cream. Well, ice cream. We can have a milkshake. Okay? So here we go. Okay, so here we are. How many strawberries are you going to put in this?
10.
Well, let's say that you're making, you've got a big blender. Okay, you got the big Ninja that you're working with here now, and you're making one for all 3 of you girls, just to hopefully, for God's sakes, wake you up. Okay? So we're putting 20 strawberries in there. So here I have 20 strawberries. Okay? Of those 20 strawberries, on the side of one of those strawberries, you know how they have kind of the seeds on the outside of the strawberry? Yeah. I'm going to circle one of those seeds on the outside of that strawberry. And I'm going to hold the strawberries up here. And I know that I'm going to hit the go switch on this blender. And I'm going to blend this for how long? 25 seconds, 30 seconds, 25? How smooth? 30 seconds. We'll say 30 seconds. But I'm going to predict where the one seed out of these strawberries, where it's going to wind up after 30 seconds in the blender. Can you kind of see how forecasting can be a little tricky? That's kind of what it is, especially in the mountains. Because in the mountains, again, you've heard me say this, it's weather in a blender. That's kind of it. When those winds start coming over these ridges at 20 knots, a 10-degree difference in vector from where those winds are can mean the difference in us getting a dump of snow or no snow.
Dump of snow.
That's how difficult it is to predict what's going to happen here. But we do rely on these forecasting tools. So, let's start taking a look at them. Low-level, significant weather prognostic charts. So these are going to be prognostic charts. Prognosis is what? Here's the prognosis. You have a diagnosis. Here's what I think. Here's the prognosis. Here's what I think will happen, right? So the prognostic look for this is going to be, here's what I think will happen. Right?
Yes.
So when we look at these, and I'm going to show you this first, this is an example of one of the low-level prognostic charts. Low level. I'm going to go back up here. Let me switch to this. So, when we look at this, there are 4 panels. When you look at these panels, what's the difference? What's the difference?
The right 2 are surface analysis, the left 2 are something else.
Left-hand panels are 12-hour forecasts. The right-hand panels are 24-hour forecasts. Okay? The 2 on the left are 12-hour. The 2 on the right are 24-hour. Then in the upper panels, we're looking at significant weather up to 24,000 feet, up to flight level 240. Okay? You're going to have IFR conditions, marginal VFR conditions, VFR areas. VFR areas are not going to be outlined. If it's not IFR or MVFR, it's going to be everything else, and that's going to be VFR. You're going to have turbulence that's going to be shown again. These are in the top panels. The upper left panel is a 12-hour. The upper right panel is going to be a 24-hour, correct? And these are going to be significant weather prognosis. This is where we expect areas of significant weather. Freezing levels. Then the lower panels, we're going to be looking at surface prognosis, because remember, the top panels are going to be up to how far, how high? 24,000 feet MSL, flight level 240. Down below it, we're looking at surface. What's going to be happening on the ground? Where are the pressure systems? We can also take a look at their movement. And we can also predict areas of precipitation or thunderstorms. That's what we're looking at here. Now, on this is one of those things that on the electronic portion of this may require a little work on your part to figure this out. But now here's the key. Down at the bottom, and it's hard to see on this because you're reading sideways, you have a valid time on this. Okay, kind of when this report, what it's good for. That's kind of what it says. Then in the middle section of this, it shows you these areas. It kind of gives you the key to solving what they are. But again, you're not going to know what they are if you don't know that the top is going to be significant weather up to 24,000 feet. The bottom is going to be surface. Upper left is 12-hour. Upper right is 24.
Can you say that again?
Nope. This will be the third time and the last time I say it. The top panels, both left and right, significant weather up to 24,000 feet MSL. Bottom panels, surface. Left side, 12-hour. Right side, 24. Okay. What kind of a chart is this? You wrote it down at the heading. You know in your notes when you write down the headings? Okay. These are going to be our prognostic charts. In your books, you are going to have to look at these and know what kind of maps you're looking at. It is very important that you understand the observation maps and the forecast maps and to know the difference between them. The FAA is going to ask you some tricky questions on those with regard to these maps because one is an observation, one is a guess. This is happening at some point here, kind of now, this is what we expect in the future. What we're talking about now is what we expect. Forecasts. Now, I want you to make sure that you have finished reading the balance of this by tomorrow. Tomorrow we are going to knock out the tafs and we're going to prepare for the quiz for Friday. Okay? Quiz for Friday. Weather. And when I say weather, I mean all weather. Yes, dear.
Is it a prepware one or?
No, it's prepware.
Okay.
Yeah,
It's going to be on the
weather.
weather. So everything weather on prepware, which I believe
From
is
weather
2
theory,
chapters.
from weather theory to right now.
Will we be
Okay,
doing like
but-
the charts and everything like that?
Yep.
This?
Yep.
We need to, like, look at the maps of places and we're like, what's happening here?
Look at the books.
Prepware question.
Look at the books. Do your prepware. Get into Big Blue. Look at your figures and legends. Live with those figures and legends. That's what you're going to be tested on. Okay?
Do you want us to turn this into
Oh, yes, please. Let me have your metars. Let me have your metars.
stapler or
I do have a stapler, Steph. It's on the desk. Would you grab it? If you've got multiple pages, guys, if you've got multiple pages, keep your decoder ring. Yeah, yeah. Just set them on the desk there, Gavin. Set them on the table. Yeah, just set them there where Harris started the stack. That's fine.
Should I turn this
Yes,
here
yes.
and then recycle this one?
Sure, sure. Yeah, I just need to make sure that I get.
sorry.
Sorry.
Okay.
Sorry for typos, certainly.
Did you like that?
Yeah.
Okay, guys.